And off we go. Okay, so let me find some logarithm content for us. Doot, doot, doot. I hated having to review my videos because are you the same where you hear your voice and you cringe?
Oh, I hate it. Yeah,
Isn't it awful? Like, what do we do to
yeah,
ourselves as humans?
I hate it. Yeah,
Like, why is that?
I don't know. I don't know. Because I feel like we sound normal to others, but then
Right.
I
And then
still
you listen to
cringe.
yourself and like, how does anybody put up with me at all? Like, why do
Yeah.
people listen to me? Ugh. It's like nails on a chalkboard sometimes. So anyway, I would hate editing and reviewing videos because of that.
It makes sense. I'm the same way.
All right. So logarithms, don't like them, or like your level of knowledge is zero.
We did them last year, and I don't think I could tell you a thing about them.
Okay. Okay. The logarithm is, you can think of it as a question. First of all, it's a way for scientists, really is where it came from, scientists slash mathematicians, to deal with really, 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 really large numbers and really, 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 really small numbers. So like exploring the universe or whatever, or looking under a microscope and having to
Okay.
measure and be able to represent that on paper.
Mm-hmm.
So that's their necessity. Um, and then um, financially, uh, growth or earning interest and charging interest, logarithms. Okay, specifically natural logs. Okay, so if I have log, I don't know, base 5 of 25.
That's 2?
You know, it's so okay. You're sandbagging me.
Because I remember it's something to do with the roots.
Yeah, right. That's the question. 5 to what power is 25?
Mm-hmm. Okay.
Right. So then the exponential equivalent, this is 5 squared equals 25.
Yes.
Okay. Um, so graphically, let's take a look. I like to be thorough. Um, since we're doing 5, why not? Sorry. Okay, so the exponential graph and the logarithmic graph, the exponential function and the logarithmic function are inverse functions of one another. So are you familiar with inverse functions and their graphs?
No.
Any function and the graph of its inverse.
Is it like reflected across the thing?
It
I'm not
is.
sure.
Across what? Here's a hint.
Um, the diagonal.
Yes, and the equation of the diagonal is
Y equals X.
you are totes holding out on
Makes
me.
sense.
Have I explained me saying totes yet?
No.
So this is y equals 5 to the x. And you know that's the exponential one because it's growing exponentially, right? It's like up for, very, very quickly.
Mhm.
And then this is y equals log base 5 of x. And this is y equals x. So exponentials, exponential and log functions, logarithmic, are inverse functions.
They're inverse of each other.
Yep.
Okay.
As long as they have the same base and exponent, right?
Mhm.
Yeah. Okay. So I wanted you to know that and see that. That is important. And so then, your common log, I think we talked about this. Log x is your common log.
Yeah.
And it has a base of what?
10.
Good. Common log. And we don't write it because it's the common log and it's base 10. And then we have our natural log. And it has a base of e. And they're used so often, they get their own notation. That's all.
Okay.
Same rules, like people like, well, is it the same rules for natural log? Natural log is a log. This is
Okay.
log base e of x.
Yeah.
Okay. So log is a log is a log is a log. Okay. So you need to be able to quickly go from logarithmic to exponential. So I'm just gonna verbally ask you to do this. Because you nailed it before.
Mhm.
So like, I don't know, 1e, what would be the equivalent exponential form be?
2 to the power of 3 equals 8.
Excellent. And what would be the logarithmic form for g? That's
Okay.
harder in my mind.
Log, hold on. Log of, so log 2 to 1/2 equals -1.
Good. You would say it log base 2 of 1/2.
Okay.
Okay. Note that one thing that helps me is, so we said, oops, we said, or you said log base 2 of 1/2 equals -1, right?
Yeah.
So the base of the log and the base of the exponent are going to be the same.
Okay.
Makes sense, right? Of course they are.
Yeah.
Okay. All right. That is like, I call that going back to mama, because half of dealing with logarithms is being able to go back and forth between logarithmic form and exponential form.
Yeah. Okay.
Okay. So you have your IB formula book, right?
Yes.
Or you're able to use it. I don't know if you have it in front of you. That's no big deal. So the rules for logarithms are there, or the rules that they give you, not all of the rules.
Mhm.
And there they are. I imagine this is probably where your difficulty lies in dealing with logarithms. Totally understandable. So we will focus on that. So here up, I did that because up top is the mother relationship, right? They have this
Yeah.
for you. So it's not something you have to have memorized, but it's good if you can do it without having to refer back to your formula booklet, obviously, right?
Okay.
So the basics, see if you can do this. So it says evaluate, which means find the value of. So what is, we'll go with E again. No, we'll do something simpler. D as in David. What is the value of log 2 of 4? Log base 2 of 4. It's 2. What about N?
Oh, 1/3.
Yes. What about Q?
Mm, 0. Is
And I'm
that
going to
true?
say because, and then I want you to give me the exponential form. So log base 4 of 1 equals 0 because
Because anything to the power of 0 is 1.
specifically 4 to the 0 equals 1.
Yeah.
Like specific
Yeah.
to that, but yes,
Yeah.
absolutely. Ooh, what about 5? You might have to, do you have pencil and paper in front of you? You might have to do that. I don't know. You're pretty
Wait,
good.
5? Which one's 5?
I went all Roman numeral on you. V.
Oh.
Can you believe that? I don't,
Okay.
I did it without even,
Oh God. No, I wouldn't know. I wouldn't know. I need paper. I don't have paper. Could you explain it?
sure. So I need to combine these somehow, right? And this is a lot to do with logarithms. Okay, so I'm going to find the same base, right? So 25, couldn't I rewrite that as 5 squared?
Yeah.
And couldn't I rewrite this as 5 to the 1/2?
Yeah.
So are you okay that this is equal to log base 5 of 5 to the 5/2? Because we
Yes.
went right to the 2.5 power. Are you okay with that?
Yeah.
So do you know what it equals?
No.
Okay. Let's go back to D as in David. Log base 2 of 4 equals 2 because 2 to the second
Oh, 5
power.
halves.
Yay!
Yeah. That's so simple.
It is. And they do not have that on the formula sheet for you, but it is among the most useful formulas. Log base A of A to the X power is always equal to whatever the exponent is or whatever the power is.
Yeah.
Right?
Yeah.
Okay. Helpful so far?
Yes, very helpful. But then when I look at something like W, I don't know. I wouldn't know.
Okay. So yes, you do. You do. What's the base?
3.
3. Can I write 27 with a base of 3?
Yes. Probably cubed, right?
Good.
3 cubed.
Can I rewrite a radical as an exponent with an exponential power, I should say?
It's a fraction, right?
Yep.
3/2?
Yes. No.
2/3?
Yes. I'm sorry. Sounds like I'm purposely being mean, right? Like,
No, it's okay.
like the boys you saw out last night.
Yeah.
So here's the rule. So a to the m over n is equal to the nth root of a to the m, which is also the nth root of a with the m inside. But in this case, we're always thinking outside, whatever.
Okay.
2/3, right?
Yeah.
Well, I've got this pesky one there.
Yeah.
Can I write it in the numerator?
Just,
Go ahead.
yeah, just -2/3. And then the answer is -2/3. Okay.
You did very little logarithmic things there.
Yeah.
It's only
It
the
just
last
looks
thing.
scary. Yeah.
All right, see if you can do x.
Okay.
And if you want to skip steps, you can. If not, whatever.
No, I don't I don't go. See, I don't know where to start with that 2 and then √2 for some reason.
Well, you can always write a radical as an exponential form, can't you?
Right. Oh, 2 to the 1/2.
Haha.
That still doesn't come like instantly for me.
Now it does.
No, it does. Right. 3/2, and then log base 4 into the negative, so 2 to the -3/2.
Well, actually, let's not make it negative yet, because
Okay.
we really want a base of 4, don't we?
Yeah.
Okay. So my suggestion is to rethink 2 at this point as the square root of 4
Okay.
to the 3/2, right?
Okay. So then it's square root. Then there's a weird fraction going on. Is there not? Yeah.
Right?
Yeah.
Okay, so maybe you don't have to write this step. You can go right to 4 to the 1/2, right?
Okay.
And exponent to an exponent, what do we do?
Multiply.
Yes, she says with absolute confidence. Oh, darn it. I didn't do the 1/, did I? Here, so let me do that. I don't know why I did that. Okay. You see where we're headed, right?
Yes. Kind of.
In
Yes.
fact, well, I think you know the answer. So this is
Yes.
3/2, right? Log base 4, 1/4 to the 3/4. So you know the answer now.
So it's -3/4.
Excellent.
Makes sense.
Here's what happens a lot, just in the middle of problems, right? There'll be something like log of 10, like in the middle of an equation or something. Well, what's log of 10 equal to?
1.
What's the natural log of E equal to?
E. No, 1, 2, 1 as well. Yeah.
Yeah,
1.
because this is a base E, right?
Mhm.
Comes up a lot.
Okay.
Or like log base 7 of 7, where it's the same.
1 again. Yeah.
Basically.
So
Right.
that whole thing just is the same as 1.
Mm-hmm.
So if that's in an equation, I can just kind of get rid of it.
Rewrite it as 1,
Okay.
right? Also, what comes a lot is, I don't know, log 1.
0.
Excellent. Log of any base of 1 is 0.
Okay.
That corresponds with the exponential equation a to the x. And that corresponds to the ordered pair 0. When x is 0, this is equal to 1.
Okay.
So
Would you
basically,
ever get?
go ahead.
Would you ever get, like, let's say you had log base 1 of 1.
Mhm. You can use
Can't that mean anything?
any base in the world. Any number can be a base.
But then I just that confuses me, because then it is kind of just hypothetical, but 1 cubed is also 1.
Yeah,
Right?
but 1, yeah. 1 to the 1 is 1. Yeah.
Yeah. Okay. Yeah, that makes sense.
Oh, you're saying why isn't it 3? I see.
Right. Right.
Well, we can write it however we want, whatever's I have to look
Right.
that up.
So
You just brought up a
it's a big
point, and
question.
I have never ever seen it in an equation, and I've never
Yeah.
seen it addressed in a textbook, and I've never thought about it until this moment. How about that?
Okay.
So there we go. We're learning from each other. So
Yeah.
let's forget that I just said that, because I almost said, well, you can use it however you want it, but that's not true. No, you
No.
can't, you know. Then the Big Bang would reverse itself and off
Yeah.
we would go. It's like dividing by 0. Don't do it.
Yeah.
The consequences catastrophic. Okay.
Right.
All right. Here we go. You ready for the big time?
Yeah.
So
Log
laws of law.
15.
Oh, so you know it.
I saw the equation. It makes sense.
Okay, so I'm going to write, this is the product. I don't want to say product rule because that comes up in calculus, right?
Hmm.
So it's
Yeah.
multiplication. Yes. Couple of things. One, this is equivalent to a to the m times a to the n equals a to the m plus n, doesn't it?
Right. Yeah.
Okay. Also, caution. Log of 5 times log of 3 does not equal log of 15.
Okay.
Okay.
That
Right.
is log of 8, isn't it?
So B is what?
B is, hold on. Oh, it's minus. Hold on.
Yes.
Hold on. 3 log 3 log base 3,
Which
Okay.
equals?
which equals 1.
Yay. Look how much you're learning.
Interesting. Isn't that just log base 2 too?
What is?
The 1.
Yes.
That makes sense.
You don't know how
Okay.
long it takes a lot of students to do that.
Oh,
That's why I'm so excited.
I'm glad.
Why do I keep writing equals? I can't contain myself. Minus log 2 of 2 equals what?
Log base 2, 5/2.
Good. Let's do some more. Want to?
Yeah, sure.
Can you still see those okay?
Yeah.
Okay, so then so these guys are all the time, right? And then this one is a biggie. If you have log base A of X to any exponent,
Mhm.
you can move the exponent out in front to become a coefficient,
Oh yeah, that always confused me.
and vice versa, right?
Yeah.
You can take the coefficient and make it an exponent,
Okay.
depending on your needs.
Okay.
Okay. All right. So why did I do this to you? Let's try H, 1H.
Log base 550.
Well, I copied it wrong. That's correct. This is a 4. You were correct.
Log base 525, which is 2.
Amazing. Good job.
Thank you.
What about K?
Um, so that would be log base 3 of 3, which is 1. And then you have the 1 again, so it's 0. Is it? I'm not sure.
Sure. Like you don't even have to change it to 1, right?
Yeah.
This whole thing is a number, right?
Mm-hmm.
A logarithm is a number. So the same rules apply. Same thing minus same thing is going to be 0.
Yeah.
One L, because I know your love of fractions.
Yeah. How do you do? Because so I've multiplied log 3 and log 7, which is log 21. But then how do you multiply that by 4/3?
Give me, I'm thinking about something. Hold on 1 second. You should go left to right just to be safe.
Yeah, okay.
And actually, it's going to make it easier on yourself. So I think your question is, how do you take a whole number times a fraction?
Yeah.
I will not make fun of you.
Okay. It's the simple algebra, you know. That's what I'm missing for the most part.
Okay, so I don't know, 9, let's say it's 9 times 2/5. You
Isn't
can
that just
write,
2/5 of 9? That
huh?
makes so much sense. It's just 2/5 of 9, no?
Yeah,
Oh, okay. Yeah, it's pretty easy.
what was it?
Hmm?
Whatever, 29 times 5/3. Huh. Just like when you're multiplying fractions, right?
Yeah. Okay. Oh,
Absolutely.
okay.
So this would be log, that's why I said it, make it, in this case, it's easier if you go left to right because the 3's cancel.
Okay.
That's all. But you're still taking a whole number times a fraction, so either way.
Mhm.
So the lot way would be, oh, I did get it right. So 21 times 4/3, the 3 cancels, this becomes 7.
Oh, and but you could also, let's say you did, because in my brain it makes sense to go 4/3 is a whole 21 plus a third of 21, which is 21 plus 7.
That's amazing. Who thinks like that? Nobody. Where did you get that?
I don't know, it just makes sense. That's how I taught myself to do that, but it doesn't always work.
That conceptual
Yeah.
understanding is fantastic. Really, really
Thank
good.
you.
Well, in my warped way, no, right?
Yeah. Let's
So
see.
whatever. But
Mhm.
but you're totally good. You're totes good. I say totes to be annoying to the younger generation. How's
No,
that?
it's great. I love it. I don't hear it very often, so it's
Well,
nice.
it's old, and I do it to try and make people, young people, think that I think I'm being really cool, but I'm just
It's
trying to make them cringe. That's all.
it's great. It's great. You would like my dad.
And so then I'll throw something down like, oh man, that's bussin'.
Oh wow. Oh wow. Yeah, that works.
My daughter's a senior and she will have none of it. And then
Yeah.
sometimes she'll tell me things to say, like slapping is old. That slaps.
Oh yeah. Yeah, I don't say that. That's American.
That's old. Oh, okay.
Yeah.
Anyway, I suppose we should do some. Sorry. Okay. All right. Let's do some more of this stuff. See, you start using the rules and you don't even need this, right? You already know them, right? But it's there if you panic.
Okay.
Like for for instance.
Could you make the 2 into 2 1s? Is that allowed? Like, let's say I did
Didn't even think of that.
log 10, 10, and then log 10, 10 as well. And then log base 10, 7, and then you just multiply those. Could you do that?
Right?
Yeah.
Yes. Now, what I was thinking, that's really good. What I was thinking is log base 10 of 7. And if I want to change this to base 10, log base 10 of 100.
Oh, right. Yeah. Makes sense.
Your way is perfectly fine. I think it's a little longer, maybe. Like if you had,
Yeah.
like if you have a 13, like log base 7 plus 13. Well, that's a
Yeah.
little, okay. What did we say? Log 700. Okay. Let's do F.
Mm. So I'd have to find the 4th root of 10 or whatever. Yeah.
Well, you could start by saying 10 to the 4th, right?
Yeah.
At least to write it down in your head, and then you see it on paper and you're like, oh, okay, so log
Over
base
10,000.
minus 10,000. And as you go, you'll come up with little tricks for your own
Yeah.
mind, right? Ugh. Like I have to do this. I can't, here's what happens. I lose my confidence,
Yeah.
right?
Easy.
Okay. So 5 over 100 is 1/20th, right?
Yeah.
So 5 over 1,000 would be 1/200th.
Yeah.
Which is perfectly fine, or we could get cray cray
Oh, right. Yeah.
and do that.
Yeah.
Okay.
Great.
Any, that was never even that's never, right? I mean, that's not a thing ever.
I don't know. Maybe.
Does anything look bad to you here that you would want to practice?
G.
Only because it has
Letters.
variables,
Yeah.
constants. Actually, they're constants. Okay. But if I did 4 plus log 50, for example, you wouldn't hesitate, would you?
No.
No, not at all. So I have to write this as with a log of base 10.
Yeah. Um.
That's my
So
hint.
log 10 to the power of t.
There you go.
So that's log tw.
No, the W is just a number.
Oh, right. I see. So log W times 10 to the power of t.
Yeah, or 10TW. It's awkward because of the exponent.
Can you explain the process again with the turning the 4 into the log 10 to the 4th? Because I'm not completely clear on that.
Yes, you are. You just forget that you are.
Yeah. Right. But hold on, let me think for a sec. Oh, yes, that does make sense. Okay.
Okay.
Yeah.
Okay, I'm gonna do, how we doing on time? We're doing good.
Yeah.
I'm gonna do some examples for you. All right. So single logarithm or rational number, whatever. So here we're going to use this guy because we have a coefficient. So we can make it an exponent.
Yeah.
Same thing here. And maybe you can do this in your head, you know, and skip this step eventually. Good.
Yes. So log 9 plus log 1000.
Mhm.
So that's log 9000.
And this is the reason I wanted to do it is we have a new rule. It's called change of base. Okay, are you ready? Hold on. Just hold on to yourself or
Okay.
be prepared to be,
Okay.
I'm warning you.
Okay.
This is the
I'm
change of
prepared.
base formula because from what I hear, it's all about that base, about that base, about that base, about that base.
Yeah.
I just heard it. I don't
Yeah.
know.
No, you're right.
I don't know.
It is.
It is because
Yeah.
it's a change of base.
Yeah. Hold on, I need to recover. Okay.
It's not about that base actually too. So now I'm a little embarrassed about that. So we'll come to that where it is about that base. Okay. So there are certain numbers that you look at and you need to think a couple of things immediately. So I think we talked about one time, like your perfect squares, you need to look at them and, you know, right at the forefront of your mind, that's a perfect square,
Mhm.
right?
Yeah.
Same thing with perfect cubes,
Oh, yeah.
especially with logarithms and the first five, you're fine.
Okay.
So what are the first five perfect cubes?
Well, 1.
Yeah, one doesn't
Um,
count, but I just
oh,
include him because he's always feeling,
okay.
you know.
Right.
Mm,
8,
mm-hmm,
27,
mm-hmm.
Yeah. Lost.
No, 1, 8, 27. Yes,
And then 125.
good. How'd you work out 64 finally?
I did 4 times 4
Hmm.
times 4.
It's 16. You
4
did 4
times
times
4.
4, right?
Yeah.
And then how did you do 4 times
16.
16? That's my question.
I did 4 times 10 plus 4 times 6.
That's what I was gonna teach you. Okay, so, oh my gosh, perfect cube. And so the base would be 2, right? Oh, it is about that
Yeah.
base.
Yes.
Lo-
Wait, why would the base be 2?
well, okay, so you can rewrite it as 2 cubed. No, okay, I'm sorry.
Oh,
Not
yes,
the
that
base
makes
of the
sense.
log. Not the base
Yes,
of the
the
log, the
base.
log base of
Yes.
I'm so sorry. Okay.
Yes, it's okay.
And 4, we can rewrite with a base of 2 as well.
Yes.
Oh,
It's fair.
right?
Yeah. And you can put them in front.
Yes. What happens?
It's just 3/2.
There you go.
Makes sense.
Yes, 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 yes. We'll end on 1. See if you can do it.
Ooh, wonderful. 25 over 0.2, no?
Say that again.
Just 25 over 0.2? Do they cancel? No, they don't cancel. I changed my mind. I take it back.
Right?
Yes.
I forgot to put that caution one for you.
Makes sense. Do you put the, I don't know. Oh, log base 3, 5 squared. So 2 log base 3, 5. You just, can you not put the 2 like?
Yeah, I'm just saving it for later, but I'll do it.
Okay.
Yeah. Okay. You're already there.
Oh,
Okay.
I thought I did it wrong.
Nope. I'm
Okay.
sorry. I'm
No,
sorry.
that's all right. And then the bottom one has the same base now. No, it already did. So the bottom one, 0.2, can be written as, is it to the power of, so it's 2 to the power of,
Don't do
no?
that. It can be, but let's think of it a different way. Remember place value?
No.
Yes, you do. So I'm sorry. I keep doing that to you. Sorry.
It's okay.
What place is that?
The first place?
Hundredths.
Hundredths. Oh, like that. Oh, wow. Yeah. Okay. Tenths. Ones. Firsts. Point ones. Tenths.
Tenths.
Yeah. Then hundredths.
Hundredths.
Yes.
What place is this?
The tenths.
Tenths, which means this is equivalent to 2 out of
10. Oh, I see. So 1/5. Ah, okay. So you just put the -1 in front and then take everything else away. You want 2 over -1. Yes, that makes sense.
Good.
Yeah.
Okay, so mom emailed me right when we started and said Thursday at noon.
Okay.
Okay, so we'll see you then, but two things, two goals between now and then. You ready? Goal number 1, try not to go to a rave the night before again.
No, I didn't. I just stayed late.
Wink, wink. No, I'm kidding. Number 2, and everybody needs goals, right? That's why I'm going to give you one. Stay out of prison between now and Thursday.
I will. I
Okay.
promise.
All right.
Yeah.
All right. We'll see you Thursday. Be good.
See you.
Bye.
Bye.